Hello my viewers, thank you for subscribing to my YouTube channel and also for watching our content and even commenting. If you haven't subscribed, please subscribe. That subscription means a lot to us. So today we are telling you the story of a young innovator, and not just an innovator, a person who is making drones and also plane models. The interesting part about this guy is not the person you will see in an aviation school. No, this guy is inside, in the interior of Murang'a County. So let's go to Murang'a. So we have arrived at our innovator's home. So we are expecting to meet our guy today, the innovator that I've told you about, and we expect to find him this gate. So at this open gate, yes. Mr. Esbon, yes, you can see yes. Asante sana, karibu. Yes.
I am Davis Esbon. I am an innovator, aviator by passion. It's good to have you here. Welcome to my makeshift innovation lab.
Sawa sawa, twende. How hard is it to convince them that you're just a guy from Kenya? Kenya is not even known for aviation, and you just request them? I mean, how easy or how hard was it?
It's quite complicated.
Yes.
Because there are also other plans that I haven't even managed to get.
Yes.
But you find that for most commercial airplanes that are out there in the market, there is at least some source of information. For instance, you will get the manuals that that come with the airplane. The manuals come with the specifications of the aircraft. So you will get you won't get the in-depth information on the material and how it's been made and the like.
Yes.
But you can get the information about its length, its width, its dimensions, how does the wing look like, what's the sweep of the wing.
Okay.
And now based on that, you
All
can
right.
develop plans.
All right. Now, like based on what's the capacity of now the commercial model of this one?
The commercial model of this one is it's around 250 something feet or 200 and something feet.
Yes.
I believe.
Yes.
This one here was is about 4 feet.
All right.
Yes.
Okay, so it has got the 4 engines and
yes, it's a 4-engine plane.
all right.
And it's a twin decker.
Okay.
But now the one that's an exact scale replica
Yes.
of an existing model
Yes.
is this one.
Ah, okay.
So this is an exact scale replica.
Yes.
So this is a representation of an aircraft that's called the Bombardier CRJ700. It was made by Bombardier.
Bombardier, is that a company or a guy?
Yes, it's a company.
Okay.
It's called Bombardier CRJ.
All right.
Meaning a Canadian regional jet.
All right.
Right as of now, it's been bought by the Mitsubishi Heavy Industries, so it's become the MRJ.
All
so
right.
it's out of production as the CRJ at the moment.
All right.
It's one of the most ideal domestic airliner.
All right.
It's a regional airliner. What regional airliners do is they connect the big airports to the small airports.
Oh.
So for instance, I want to fly from Kenya to Dubai, and maybe I can't find the big jet in my airport at Mombasa. So I will go and pick up a regional jet that will take me to the big airport, the international airport, where now I can connect to my international flight.
Okay, now these are okay. I don't know much about that.
Yes.
I'll just ask you the questions where I can, where I know or where I have some understanding.
Yes.
But in as much, I will seek to get more understanding from you.
Yes.
No, this plane,
Yes.
these are the engines.
Yes.
So it has twin engines.
Yes, it's a twin engine plane
All right.
that are rear mounted.
But most of the planes I can see, even the ones I see in your model in your lab here, they have got their engines behind there, just below their wings.
Yes.
Why does this one has the engines on the hips?
Very good question. That's
Yes.
a very good question. So I'll give you some technical explanation to it. There are some advantages to having the engines at the rear of the fuselage or at the wings. So as the designer of an aircraft, you make consideration based on the model or on the aircraft you want to build. So you have to make a balance between efficiency and design consideration and existing design that you already have. So when this one was being made, they figured out that if they can put the 2 engines at the rear, the wing can be cleaner. So by that I mean there's something on the wing that's called aerodynamic profile of the wing.
Yes.
So the aerodynamic profile of the wing will dictate how efficient a wing is at producing lift.
Yes.
So when we are making an aircraft wing, we want it to be as smooth as possible so that it slices into the air in the smoothest and easiest way possible.
Yes.
So when the engines are below the wings here, there is some disruptions caused by the shape of the engines.
Okay.
It's called it's a type of drag.
Yes.
There are various types of drags that are acting on the plane. We have interference drag, foam drag, and the like. So the engines will cause some drag, and now that will disrupt the airflow over the wing. So this will reduce the efficiency of the wing producing lift. Lift, which is what is lifting the aircraft into the air. So when we can have a smooth airflow
Yes.
over the engines,
Yes.
that over the wings that is uninterrupted, we can
Alright.
develop more lift for the same size of wing.
Okay.
So that's why you see even this plane, from the look of it,
Yes.
the wings are quite small
Yes.
compared to the fuselage.
Yes.
It's something that was built that way
Yes.
because the wing is clean enough to produce the same amount of lift that will be needed if these engines were here,
Yes.
the wings would have to be bigger.
Wow.
Yes.
That's quite interesting.
Then it comes with at its own cost also. So there are some savings you will make. For instance, I can have a bigger engine because I won't be restricted by the size of the landing gear,
Yes.
which will restrict the size of my engines here.
Yes.
Because if I put a bigger engine, I will have to put longer landing gears so that the engine does not touch the ground.
Okay.
But if I put them here, I can have them big. However, there are some disadvantages to it.
Yes.
Like this tail is
Yes.
called a T-tail.
Yes.
When you have the engines at the rear,
Yes.
you can only make the tail T-tail. So the T-tail, the tail is at the top, it forms a T
Yes.
shape. Then the conventional aircraft, you'll notice
Yes.
the tail is at the bottom.
Oh, yes, yes, I've seen that.
The tail is at the bottom.
Yes.
So this one is more efficient because it's getting some wash from the wing.
Oh,
So
okay.
some of the air flowing over the wing
Yes.
will also touch this
Will
one.
touch
So
the
the
tail.
tail is very effective.
Yes.
Now this one,
Yes.
considering that we don't have that, the wash here is not coming to the tail. The tail is a little bit less effective.
All right.
So it's prone to something we call a deep stall. So
Okay.
when the aircraft stalls,
Yes.
it goes all the way.
All
Yeah.
right. That is that's
Quite
very
some
interesting.
technical,
Yeah.
but it came with its own advantages.
Yes.
It was quieter on
Yes.
the fuselage.
All right.
It was more efficient.
Yes.
But also it needed some complicated design here
Okay.
to make this part very much reinforced so that it can handle
Right.
the engines.
Another thing I've seen,
Yes.
there are less chances for stowaways to hide in the plane. You know, someone wanting to be flown from Kenya to Heathrow
Yes,
airport
yes.
in the UK, because I've seen such instances.
Yes.
And by the way, if I ask you, how does someone hide in an airplane like this, actually outside the airplane, and then reaches to the UK, and amazingly, you might find people who are still alive,
Yes.
considering the air pressure, considering the airflow. How possible is that?
It is possible, but very risky.
Yes.
It's a very risky
Have
thing.
you ever tried to?
I wouldn't try that at all. Some risks are not worth the trial.
Yes.
Because that will involve, the first risk is sneaking into that aircraft in
Yes.
itself. You see, bleaching the wall, the security perimeter
Yes.
of the airport in itself is a task.
Yeah.
So that is the first challenge.
Yes.
Then after that, you need to identify the specific aircraft and know that it will be going to that destination.
That is going to Europe.
Yes, we might be thinking it's going to Europe, but the plane is going to
Kisumu.
Yeah. So you must be also, I think, have done your research a little bit.
Yes.
So once you identify the plane, the most potential place you can hide is the landing gear.
Right.
Because that's the most accessible one you have.
Okay.
If you are good enough, you will manage to hide, but the elements of weather will
Yes.
act so much on you, which it makes it very unideal.
Okay, now let's go to another model here.
Yes.
This one looks like the one I see at Wilson Airport.
Yes.
Yes. You can perhaps tell us what the commercial model of this one,
Yes.
where I'm likely to see it,
Yes.
in some of those questions.
This is an RC model of a Cessna 172.
I've heard that name, Cessna.
Yes, the Cessna 172 is a very common aircraft. Most pilots who have flown,
Yes.
they have trained in the Cessna 172. It's the world's most produced aircraft. Been lots of years, I think in the 1960s or 50s, that's
Yes.
when it started production.
Okay.
This is a scale of the Cessna 172 also. It's still incomplete. I'm not done with the landing gear yet.
Yes.
But the Cessna 172 is basically a trainer. It's a high-wing training aircraft.
Oh, right.
It's used for training pilots.
Okay.
Yeah.
Halafu kama ile ya Mr. Bones, I've seen some of Mr. Bones movies.
Yes.
So is it a Cessna?
Yes, it was a Cessna 152 and
All right.
150.
Okay.
One of the it's a horse of the sky.
Oh, right.
Yes, this thing will fly anywhere.
Yes.
And having the high wing gives it very ideal characteristics
All right.
for bush operations.
So it can even land just a
Yes.
place. It doesn't really need to be on
Yes,
an
it
airport.
doesn't need a paved runway for
Yes.
it to land. You can land on the road, you
Yes.
can land on the unpaved runways and the
Right.
like.
Yes.
The design of it, the
Yes.
fact that the wing is high,
Mhm.
makes it very forgiving to strikes on the wing when you land in uneven surfaces.
Okay.
And also its handling characteristics
Mhm.
make it very good at landing at low speeds.
So now let's go to this other model here.
Yes.
This one looks like it has a motor fixed.
Yes.
And some electrical components. I
Yes.
don't know what they are. Maybe you could explain to us. You tell us what model this is,
Yes.
and where I'm likely to see it here in Kenya.
Okay, so this one
Yes.
is a Cessna 172.
Yes.
This is a bigger model of this one.
All right.
This it's an RC controlled, meaning remote controlled.
Oh, okay.
So you fly it by means of a remote.
Oh.
Yeah, so I am assembling it
Yes.
for the purposes of seeing if it can be used
Okay.
for training.
All right.
Yes.
So, it has those
These
wings.
are the wings.
Okay.
Yes.
All right.
The wings just come right there.
Like now, this one. How did you assemble this one? What materials have you used to make this one?
This one I've made using this very basic material. It's called Forex. It's the one that's used in making billboards and the like.
Okay.
Yes, I try to use as basic materials as possible.
All right.
Something that I can source locally.
All right.
That is what innovation is about.
Yes.
Making use of what you have.
True. True.
Yeah, so I've made it using that and hot glue.
Mm-hmm.
Just that and now plans
Yes.
that you use to get the dimensions.
Okay. About this plane,
Yes.
considering the science of flying planes,
Yes.
this one has a rotor blade here.
Yes.
Does it not interfere with the circulation of air? Because you told me that the wings have to, they don't need any interruption.
Yes.
So does it not interfere with the airflow?
It does.
Yes.
Which is the reason this airplane does not fly fast.
Oh, okay.
Yes. So in aviation,
Yes.
every aircraft design is a compromise of something.
Yes.
So you look at what you want and you look at what you can compromise.
All right.
Then you base your design on that. So this one, they needed a trainer.
Yes.
So if I need a plane for training, I need a plane that can fly slow.
Yes.
Because a student doesn't need a plane that's flying too fast.
Yes.
A plane that is basic enough
Yes.
for the student pilot to fly in.
Okay.
And a plane that is forgiving for mistakes,
Yes.
so that it doesn't kill your student in training.
All right.
So it's a very forgiving aircraft.
Uh-huh.
So among the considerations that you come up with is you need to use a propeller engine. So this is a piston engine basically. Like the same we have on motor vehicles.
Yeah, combustion engine.
Yes, so you find that they are lower maintenance than the jet engine.
All right.
And they are more ideal for the training scenario.
Okay.
Yes.
Now we would request you to take us through another model
Yes.
that it doesn't have a lot of complicated stuff.
Yes.
Because we want to ask questions.
Okay, yes. This is a model of the P-51 Mustang.
Yes.
The P-51 Mustang was used during the World War II. During the World War II, this thing helped win the Battle of Britain.
All right. So it was manufactured in Britain.
Yes. No, it wasn't manufactured in Britain.
Yes.
It was manufactured for Britain, by North American.
Oh,
yes,
right.
it's a company called North American something.
All right.
It manufactured the P-51 Mustang.
Yes.
For the British Air Force.
Okay.
So it was a very fast plane.
Yes.
Very fast and agile.
Yes.
The wing design was very futuristic.
Okay.
So it helped it cruise at very high speeds.
All right.
And would do some tight maneuvers, which outdid the Germans.
All
during
right.
the World War.
So now this one feels like it's a history lesson.
Yes, that's part of history.
And then we are coming now close to the future.
Yes.
And now we also want to learn about the drones.
Yes.
Because drones is about future. You told us that you are a licensed drone pilot.
Yes.
And that you are also licensed to fly drones.
Yes.
You also trained in drones.
Yes.
So, but we would also want to know, how did you learn to make drones? because that is not something that is taught in Kenya.
Yes.
So how did you learn to make drones? Perhaps you can even take one of the drone models that you have.
Yes.
You take us through that, and yes, you teach us about drones. Now we have this drone here.
Yes.
So tell us what is this drone made of, and what makes it a flyable object? Like how does even a drone fly? Like what is the science behind that?
Okay.
Is it the the lift, creating enough lift and all that stuff that we read in physics? I can't remember actually
Yes.
much of it.
Yes.
But I remember there was upward force, no, I think some downward force,
Yes.
some Newton's laws, I don't know, whatever things you can take us through that.
Yes, that's for sure. Now, when we talk about drones, drones are unmanned aircraft systems.
Yes.
So when we talk about unmanned aircraft systems, we mainly talk about two main branches. That is the fixed wing and the multi-rotor. So the most common is the multi-rotor. Sorry.
Yes.
The multi-rotor is a drone with multiple arms. So you find that most basic drones that people know about, the photography drones and the videography drones,
Yes.
they are mostly multi-rotor.
Yes.
They have a four is the most common, which makes it a quadcopter. So I'll start first with the multi-rotor, then
Yes.
I'll explain more on the fixed wing in a few. Now the multi-rotor is basically a robot that flies into the air. So it's made of a number of propellers. It can be 3, 4, 6, 8, or 12.
Yes.
Based on the capacity you want to carry. So the 4 is the basic, so I will use it as the explanation. These are quadcopter. A quadcopter has 4 motors, and each motor has a propeller.
Yes.
So each motor spins, and in turn it spins the propeller, which scoops air from up to down.
Yes.
So when this air is accelerated, it's pushed down at a higher pressure. So when that combination of the 4 motors pushes down,
Yes.
it's enough to push the drone up.
All
By
right.
Newton's law.
Yes.
You know that for every action there's
There
an
must
equal
be
and
equal
an
and opposite reaction.
Yes. So when the drone pushes air down, the drone is pushed up.
Okay.
So the drone takes off.
Yes.
Takes off into the air. Now once the drone has taken off into the air, there are systems that now maintain it into the air and help us to control it in the air.
All right.
So that now that is where we come into the components of a drone. We have the main controller or the flight controller. That's the brain of the drone. That one tells the drone, what do I do? What am I supposed to do? How am I?
Yes.
It's a mini computer.
Yes.
Very much of processes going.
So this
there.
this one here is like an integrated circuit. It's an
Yes,
IC.
yes.
All right.
This one.
So it has got memory and all stuff.
All that.
So let me ask you,
Yes.
if perhaps I've never flown a drone myself.
Yes.
Perhaps I have a drone,
Yes.
and then somewhere mid-air,
Yes.
it loses connection. It loses connection with the controller.
Yes.
What does a drone do?
Now the flight controller is programmed to know what to do in that case. So
Yes.
immediately it loses connection, the flight controller will know I have lost connection. So during the programming of the drone, there is a part where you tell the drone what does it do when the remote control is lost.
Yes.
So most of the time you tell it to return to home. So what the drone does is it
Okay.
returns to where it took off from.
All right.
Because it recorded its home point when it took off.
Yes.
So that's all that happens because of the flight controller
Okay.
or the main controller.
All right.
So it knows the home point
Yes.
and will just fly up
Yes.
and choose the most direct point to its home point and land.
Yes.
Another option can be it can land at the same spot.
Okay.
Yeah.
I've also seen another phenomenon, though I haven't seen it here in Kenya,
Yes.
of people jamming drones.
Yes.
Like someone has an equipment, and then they see you maybe flying a drone around their homestead,
Yes.
and then they jam it.
Yes.
How possible is that? How can you jam a drone?
That is a very possible thing, because you see, drones are basically communicating by signals.
Yes.
And if you know about communication and signals, you know that signals can be intercepted.
Yes.
And if they can be intercepted, they can be jammed and manipulated.
Okay.
So it's within the same communication frequencies. You send a signal that is almost imitating it.
Okay.
You know, these software people know how to make those
electromagnetic signals.
and all those stuff.
Yes.
So it interferes, it intercepts your drone's communication, and now starts to communicate with your drone instead of you communicating with your drone.
All right.
So they can send commands to where they want the drone to go, or maybe land.
I also have this weird thought.
Yes.
I want to, if I want to fly a drone.
Yes.
Outside or just inside State House.
Yes.
What things can I face, or how possible is that?
That is a very, very
stupid,
dangerous idea.
Yes.
Because that is now where national security comes into the picture.
Yes.
And our country has taken some very good steps towards curbing that.
Yes.
Because it's actually a very prime risk.
Yes.
When you think about drones, many people can think of such bad things to do with the drones, which is poses a very significant risk to our national security.
Yes.
Because when you fly in there, you are posing a threat to those people there, and also people who might be around the vicinity of that place.
Okay.
Now, we have very strict laws and regulations that govern us. So, if you are a pilot, there are places you are not allowed to fly in.
Okay.
We have restricted zones, we have danger zones, and we have prohibited zones.
Right.
So, you would never try to do that.
Okay.
And also, we have those jamming systems within our security agencies, so that they can take care of such cases.
All right.
Because it's a very big risk.
Okay.
Yes.
So have you tried to assemble a drone yourself?
Yes.
So how was it? How was the experience? And what did it entail?
Okay. The first time I tried to assemble a drone, I started with RC.
Yes.
So back when I was a kid in high school, I got this RC aircraft as a birthday present from my mom. So she rewarded me an RC helicopter. So that was back in 2010, around there.
Yes.
And we didn't have the hobby common here in Kenya.
Yes.
So after some time of flying it, I crashed the RC helicopter.
Yes.
And one motor got destroyed.
Yes.
But I didn't know how to fix it. So I tried to fix it, and in the course of trying to fix it, I ended up destroying the RC completely.
Okay.
So I ended up losing my RC helicopter, which prompted me to want to know how can I fix that. Now, when I started studying into how I can fix that, using RC forums and all that, I got to repair it and got it to fly. And now that's when I realized, oh, wow. So I can make things fly.
Wow.
So I started now going further and further into making RCs.
Okay.
Then I got into drones.
If someone there has a drone that needs to be fixed, so do you repair drones?
Yes, I can repair drones, because as long as you know how it's operating, and you know what is happening, you can figure out where there is a problem.
Okay.
Because there are systems, and we have also softwares that help us in diagnosing the drones.
All right.
They are sophisticated machines, so they are also examining themselves in real time.
Okay.
So fixing drones, it's something I can also do.
All right.
Yes.
I have another question regarding to the use of drones, especially in warfare. I personally do not advocate for any warfare, and I'm not saying this as a way to promote any use of drones in killing people. But we've seen a lot of use of drones in warfare. We've seen drones being used in the current Ukraine war, in Gaza, in Israel and Palestine war. Drones are actually being used because even the US uses drones severally, and even unmanned aircraft. Do you see as if the Kenya aviation industry will get to a point of using homegrown or home manufactured drones to even achieve better things besides warfare?
Yes, I believe we are heading towards that because we are making steps
Yes.
of progress in the unmanned aviation scene,
Yes.
and we are coming up with more uh, strategies
Yes.
to make the unmanned aviation scene grow.
Yes.
So the first thing was regulation.
Yes.
So we needed to regulate how people are doing what they are doing.
Yes.
So we have established good enough regulations, and the operations are under regulation. Now it's regulating what they do. We have quite some upcoming operations in Kenya with drones, like we have drone delivery of medicine. We have the Kisumu. In Kisumu, right now you get a dog bite.
Yes.
The rabies vaccine is delivered by a drone.
Yes, there's a company that came from
Zipline.
Rwanda.
Yes,
Yeah,
Zipline, a very efficient and good company.
Yes.
Because if you look at their safety record,
Yes.
no crashes in all
Yeah,
their
yeah, sure.
operations. Because drones are opening a whole new horizon
Yes.
in aviation.
Okay.
Because there's a niche that they are filling that
Yeah.
was left out.
So you feel like besides warfare, there are better ways that people can use drones to save lives instead of killing.
That's right. We have way more uses of drones besides warfare. For instance, let me just name a few. Let's think about someone is in the ocean and he's drowning.
Yes.
I can send him a lifeguard, a life vest,
Yes.
using a drone before the life boat comes.
Yes,
it
sure,
gets
sure.
there.
Yeah.
And I will be there before the lifeboat comes.
Yes.
I assume you are in the mountain and
Yes.
you are stranded.
Yes.
I can track you down with a drone.
Yes.
I can figure out where you are, whether how dark it is,
Yes.
and I can know you are right there.
Oh.
Let's assume it's this case of agriculture.
Yes.
I need to monitor my crops. I don't need to go to every part of the crop
Yes.
because I am disturbing the crop.
Yes.
I can just fly over,
Yes.
get the picture, go
Okay.
and process the data, and I know this part needs this part needs that. There's
All
a
right.
disease that might be infesting that place,
All right.
and the like. We also have other futuristic ideas like think of cleaning windows.
Yes.
We have these skyscrapers in
Yes,
the
yes,
city
yes.
made of windows.
Yeah.
Instead of a person having to go there by a crane to clean those windows,
Yes.
a drone can do that.
All right.
If we get the necessary resources, we will develop those.
So you
technologies.
personally feel bad when you see drones being used to kill people. You see, as a person who is inside aviation, you feel bad when you see drones being used to kill children.
Yes, it's a painful thing.
Yes.
It's a very painful thing.
All right.
Because it's not something that when it was being made, the main goal was not to kill.
Yes.
The main goal for unmanned aviation was to solve problems that were there.
Yes.
However, it happened to get used in the combat arena.
All right.
Which is something that was unexpected.
Yeah.
Even because considering a commercial drone,
Yes.
it's the need that arose is what created them turned them into
All right.
machines of war.
Yes, I also have, and I think this is the last political question about planes and drones and killing.
Yes.
There is the biggest commercial, the biggest cargo plane
Yes.
that was made in Ukraine. I
Yes.
think it was called Antonov something.
Yes, the Antonov AN-225 Miria.
Oh, I don't even remember that.
Yes,
It's interesting that you can remember even the code name and all that.
Yes.
No, how did you feel when that plane was destroyed by Russia?
As an aviator,
Yes.
when we lose an iconic figure in aviation,
The
it's
only
a
of
pain.
its kind.
Yes, it's the only of its kind, and it was breaking records. And
Yes.
that thing was a marvel in itself.
Yeah, it
because-
took years to make.
Yeah, and if you think of its safety,
Yes.
having survived as the solo plane and you've been flying,
Yes.
that goes ahead to tell us how well built it was.
Yes.
That thing would land in very remote areas
Yes.
that you wouldn't expect.
Yes.
It was a work of art,
Yes.
I will say so. But war happens, and it's a consequence of war.
Yes.
So we just swallow the loss and we move on.
All right.
Yes.
So I also felt sad about that.
Yes.
I'm not really into aviation. I'm just a researcher.
Yes.
And I felt bad about that.
It was an iconic plane.
Yeah, sure.
Yes.
So our mind and hearts are with the Ukrainian people. So all this shall come to end. So now we now come back to Kenya.
Yes.
and look at the way the government is handling, or the government is supporting innovators like you.
Yes.
Have you ever perhaps tried to reach out to the government, maybe to help you commercialize your idea, or even take you a step further? And what steps have you taken in that?
So basically, what I believe is for anything you want to do, you must have your approach.
Yes.
So there is the thought out approach that you take towards a certain thing.
Yes.
And one that I personally work with is the approach of first things first, is making yourself good enough
Yes.
to be competent to stand into the place that you want to start.
Yes.
So for instance, I want to bring to ask for help from the government to bring us, to help us innovating drones. It will be better if I have something I'm already bringing to the table, not
Yes.
just coming asking for help. I am coming and saying, this is how far we are,
Yes.
and with this we can get this far.
Yes.
So my approach is one of first equipping myself with the necessary skills and skills and experience.
Yes.
that will help me in boosting and bringing and pushing forward
All
the
right.
unmanned scene.
Yes.
So I have started with getting intense knowledge on the unmanned aircraft systems.
Yes.
So I have done courses in unmanned aviation. I've done courses in remotely piloted aircraft technology, so that I can equip myself with skills of unmanned aviation even outside our country. Skills that are being used in other countries to develop their unmanned scene.
Okay.
So that has been my approach for now. But with the right resources, if we can get them along the way,
Yes.
it will be a great boost.
Yes.
Because things like the research materials that we are using,
Yes.
we can get better materials.
Okay.
We can research and use better materials in our
All right.
prototypes.
So let me ask you another question.
Yes.
How hard is it to even come up with looking for those resources? Some of them, you told us, some of those resources are the ones that you can locally find.
Yes.
So how hard is it to get even the basic resources to make any of those drones or any of these models?
It is quite a challenge because number one, I am self-funded. So I fund my own projects.
Yes.
I have to figure out where I get money for the materials and all that. Depending on the materials I'm going to use, some are readily available
Yes.
and cost friendly,
Yes.
so I can source them.
All right.
But some of them, like carbon fiber and the like,
Yes.
I have to source them.
Yes.
And that is something that even impedes my progress.
Yes.
Because I have to take time
Yes.
before I can get the materials.
Okay. For instance, a model like this one.
Yes.
If you count all the material that you've used plus the labor and everything, how much has come to put this one the way it is?
The depending on the size, there is the cost that it takes. These ones were among the first ones. This one cost quite a lot.
Yes.
Because I was still experimenting with
Approximate figure.
This actually cost me 27,000.
27,000
Yes.
Kenya shillings.
Yes.
That's quite expensive.
Yes, but you can also see the size.
Yes.
It's 4 feet wingspan.
Yes.
It's quite a big one.
All right.
But now over time,
Yes.
if I can get to establish a production line,
Yes.
I have come up with a production, how do I put it? A production strategy
Yes.
that will allow me to enjoy economies of scale.
Oh,
so if
okay.
I can produce these aircrafts in numbers, in
Yes.
big numbers,
Yes.
I can produce them at a lower price.
All right.
Because the materials I use, some of the materials I use and the tools are one-time use tools.
All right.
So for instance, I have used something for fiberglass.
Yes.
It's a one-time use tool.
Yes.
But if I was making 3 planes with the same tool,
Yes.
that reduces my cost. I wouldn't have to go and buy
Okay.
another one. Then buying things in small amounts is more expensive than buying in bulk.
Yes.
So if I can get produce them on a large production line, that will be better.
Okay.
Yeah.
So, like this model, have you ever considered like selling them to aviation schools or even high schools, so that teachers can use them to teach students?
Yes, it's actually something that I'm actually eyeing towards, especially for aviation schools, because I noticed there's a problem in aviation schools.
Yes.
We are coming fresh out of high school. I am fresh out of high school. I have been admitted into an aviation course, but I have never seen a plane in my life. I don't know how a plane looks like.
Sure.
Now here the teacher is teaching me about the engine, the leading edge, the trailing edge, and he's telling me about the wingtips, and he's telling me about the nacelles, and he's telling me about the APU. I cannot visualize all those if I don't have something on hand. But with this, if I come and tell you this is the fuselage,
Yes.
it's the body of the aircraft.
Yes.
These are the wings. They are the ones that lift the aircraft into the air. These are the winglets. They are on the wingtips. These are the engines. They are rear mounted. This is the elevator. This is the horizontal stabilizer. This is the elevator. This is the rudder. This is the vertical stabilizer.
Yes.
This is the APU.
Yes.
And this is the tail cone.
Yes.
Regardless of how much of a slow learner you may be, you will definitely grasp that because you have seen it practically. When I tell you this is the leading edge and this is the trailing edge, that is an idea that has stuck in your head forever. You have known that the leading edge is the front side of the wing, the trailing edge is the rear side of the wing. But you telling me and explaining it will be a bit hard to explain the same concept.
Yes.
So it's something that I've been working towards promoting it in aviation schools.
Yes.
And also in flying schools.
Yes.
We have these flying schools where you have to learn the controls of an aircraft.
Yes.
And the axis of an aircraft.
Yes.
The longitudinal, the lateral, and the vertical.
Yes.
Then the control, the roll, the yaw, and the pitch. For you to get these concepts, in driving school we use the model town board and we use these toy cars.
Yes.
So why wouldn't we use this in aviation so
Yes.
that our students can get the concepts
Yes.
rigidly from the word go?
So you think because you've been to aviation school, so you think aviation schools do not actually have enough or do not have good models to teach the students?
Yes,
Which
it's something that's missing out.
All right.
Yes, custom built models. Because for instance, your school, you are training pilots and you're training pilots on a Cessna. I will build you a Cessna 172 and I will even paint it in the library of your school.
Yes.
So that's not something that we have available here in Kenya at the moment.
Yes.
So it's something that I'm trying to bring out and see how it will be received.
All right.
Yes.
So what is this now?
This is a remote controller. We call it a transmitter.
Yes.
Or a TX. A transmitter takes in the pilot's input, converts it into an electrical signal, and dissipates it into the atmosphere, and it's picked up by the receiver, which is on the aircraft. So it's sent out and the receiver receives it.
Right.
So this a controller is classified in terms of channels.
Yes.
Channels are the control inputs that it can take.
Yes.
So for instance, this here is an 8-channel controller, meaning it can control 8 channels on an aircraft. A channel is like, for instance, let's take throttle. Throttle is advancing engine power. So that is one channel. Throttle up, throttle down. So throttle will help us either go fast or will help us, if it's a multi-rotor, go up.
Yes.
So if we want to take off, we put in full throttle.
Yes.
All right. Now this is the second channel. It's called the rudder channel.
Yes.
The rudder controls the rudder on our aircraft.
Yes.
So when the rudder moves left or right, the aircraft moves left or right, respectively.
Yes.
So it helps in yawing the aircraft. Then we have the aileron. This is our third channel. The aileron helps the aircraft in rolling. Rolling is more like, so we say thrust is
moving forward.
yes,
Yes.
so going fast forward.
Yes.
Right?
Yes.
Then we have rudder,
Yes.
which gives us our yaw, which is this.
Oh.
That is our yaw.
Yes.
Then we have roll.
Yes. Oh, like this. If it wants to take a turn.
Yes.
All right.
Good. Then we have pitch.
Yes. Oh, okay. Elevation. All right.
Yes. So those are the basic controls of an aircraft.
All right.
4 channels. That's
Okay.
the basic remote.
Yes. Yes.
Then after that, now we have auxiliary channels. So
Okay.
for instance, you have flaps,
Yeah.
you have landing gears that are retractable,
Mhm.
you have a channel for it.
Oh.
You have a smoke bomb or a camera or something like that, you have an extra channel for it.
All right.
So now this one you can do 4 more extra channels. So
Yes.
if you are spraying, maybe the sprayer can be on 1 channel.
Okay.
Yes.
You know, you explaining how to fly planes
Yes.
using this, it makes someone think that it's very easy. Like
Yes.
I can just go into an aeroplane and maybe
Yes.
hijack a plane, steal the keys, and then start doing stuff. So is it that simple to fly a plane, or it's only that you've simplified it?
That's a good question. I believe it's simple if the person teaching you teaches you in a simplified way.
Yes.
I say intelligence is not making simple things complex.
Yes.
Intelligence is making complex things simple.
Yes.
So why would I want to make something that is as simple as making a plane go this way and going this way into a complex thing? I need to simplify it for someone, the layman, to get it without any stress of it.
Yes.
That is how a teacher or an instructor should be.
Yes.
Make something that is complex easy. Flying is difficult.
Yes.
It's complex.
Yes.
But with the right instruction,
Yes.
it's very easy to fly. Because
Right.
the same concept that you have understood here,
Yes.
you have understood the roll,
Yes.
the pitch,
Yes.
the yaw.
Mhm.
It takes students in school longer to understand because they don't have a conceptualizing tool
Yes.
to get the idea. So the reason it became easier is because I can show you and you can see it. So when the concept gets into your head, it sticks there.
Okay.
Yeah.
All right. Now you can show.
Where?
You know, I saw a documentary of a certain guy in the US.
Yes.
He was stealing planes, flying them to mountains, some villages,
Yes.
and all that. I can't really remember the name of that guy, but it was a true thing. But the way you're making it simple,
Yes.
it's I think some viewers can think that you can just go into
Plane and steal
yeah,
it.
and just
Okay.
steal it and start
Now,
flying it.
The thinking that you have to put into it so that you can be flying is the real deal now.
Yes.
Because now I said it's as easy as pitching up and pitching down. But then there's a maximum limit to which you can pitch up before your plane stalls and falls to the ground. There's a maximum point to which you can roll before your plane tips off to the ground.
Yes.
And then combining all these inputs to make them a symphony of smooth maneuvers in the air takes some time now.
Wow.
Because you need to combine them together
Yes.
and in easy ways.
That's quite interesting.
Aviation is interesting.
Yeah, it's very interesting.
Yeah.
Another phenomenon that I've seen, since several years ago, we've seen so many commercial airplanes, falling or getting into accidents, like the Malaysia plane and others. So, what causes those accidents, especially with the Boeing models?
I'll talk about air crash in general and air accidents.
Yes.
Air accidents occur mostly because of some errors in the system. We call it a chain of events that leads to a catastrophic accident. So, for instance, you find that most of the times we have the fact of the human error. Human error is when the pilot or the human element in the aviation scene makes an error. That error can be from the design, from the operation, from the maintenance, the servicing, and all the like. So you find that, for instance, let me take an example of the Boeing 737, the 737 MAX. It has had quite some accidents because of the some systems it has, like the Ethiopian Airlines crash, and we had the Lion Air crash of the same model, and it ended up being grounded. It was a system called the MCAS. The MCAS is called the Maneuvering Control Augmentation System. So that system basically was put into the plane because when they redesigned the 737 is an old aircraft from the 80s. So when they redesigned it, they didn't want to redesign the whole fuselage because that will be a lot of money. But they needed to install new engines. The new engines were heavier and bigger. So what happens is the engines had to be pulled forward, to be installed a little bit forward. So what that did, it had an effect on the aircraft's center of gravity. So the aircraft was nose heavy a little bit. So they decided to put in a system that would counteract that without the pilot having to do it. So it was called the Maneuvering Control Augmentation System, the MCAS. So when that system was installed, it had some sensors that were placed on the fuselage of the aircraft, so they would sense the angle of attack that the airplane is in, so that they could change it. However, if the angle of attack sensors were wrong, it means that the computer of the MCAS was processing the wrong information. So that's what happened. The MCAS system malfunctioned, and now the aircraft is being told that it's at a high pitch angle. So the aircraft systems tells it you need to pitch down. So when it pitches down and it's on takeoff, you get a crash.
I've also seen another phenomenon, even with our own KQ. Some planes have got some duct tape on the wing. So how does that even help?
That's a good that's a good question. And it's actually not duct tape. We have different types of tapes that we use in aviation. Mostly that's called speed tape. It's it's a special type of tape that's used on cracks and the like. It's a very high adhesive material. It's made of aluminum, same material as the aircraft body. It's used for small fix-ups. There is speed tapes, we have load tapes, we have different types of tapes, but it's a very safe one. If you see the engineer doing that before your flight, you don't need to be scared.
Be worried.
Do not be worried.
When I look at outside the window
and see the plane with duct tapes, no, don't be scared.
Alright. That's interesting. In like 10, 15, 20 years time, where do you see yourself?
The end goal is the cockpit. For me, everything that I do, I do it to get to the left seat. The left seat is the captain's seat of these commercial airliners. It's been my dream ever since I was a small kid to fly commercial airliners. But when I got to flight training, I realized it's quite a task and a financial burden on me. So I thought to myself, there are many ways to skin a rat. So what can I do? I'll use the shortest, the easiest route for me into the cockpit. So I decided to go into aeronautical engineering because my idea was there is no mechanic who doesn't know how to drive. So I don't expect to be an aeronautical engineer who doesn't know how to fly. So once I got into aeronautical engineering, it put me closer to the dream of flying. Then I decided, let me start the journey of being a pilot by being a remote pilot. I am a pilot, although I fly from the ground, I still fly in the same air. So it's a journey that I'm doing. In as much as I'm a pilot from the ground, I'm still a pilot. And it's still progress on my journey towards being a pilot. The end goal is flying these commercial jets and sipping coffee at 40,000 feet in an aluminium tube and doing 900 kilometers per hour. That's the dream. That's the goal.
Everything is possible. If you've been able to assemble all those planes, I don't think there is possibly anything that's too hard for you.
We do our best and we leave the rest to God.
That's I think that's the idea that many young people need to know out there. That you don't actually have to wait for some kind of a miracle to come and put you and take you from the village and take you to somewhere
to
where
your dream.
Where you wish to be. You have to start somewhere And we are happy that you've started by making the planes themselves.
Yeah. You always have to start somewhere.
Yes.
And it's from that the progress can be made.
Yes.
Because the only journey that's long is the one that has not been started.
Sure, sure.
But once you start it,
yes,
you realize it
becomes easier.
Yes.
All right.
This here is our receiver. It goes on to the aircraft.
Okay.
So basically our communication between me and the drone is this.
Yes.
This small module.
Right.
This is called a lithium polymer battery.
Yes.
This is the type of battery that we use for drones.
Right.
It's a more high energy capacity,
Yes.
so that you can get more endurance. So we'll first connect this one
Yes.
to our control inputs.
Yes.
These are our controls.
Yes.
We have these are our ailerons. Our ailerons are these ones,
Okay.
which make our plane go this or this way.
Right.
So we connect them on their channel.
Yes.
So each cable here represents a channel.
Okay.
So this one, we can start with this one. This is our throttle channel. We put it onto the throttle. Like that. Then we have our ailerons. Put it there. Then we have here our radar.
So how do you know they all look alike?
Yes, they all look alike, but I know them by the side they go.
Right.
And now it takes experience for you to know them.
Take me years or even
Now it's the same way it will take me quite long to do media. You see me in front of the camera?
Yes.
I'm very poor at that.
Yeah. But at least you're good at something.
Yes, when it comes to planes,
yes,
it's the one thing I know I'm good at.
That's all that matters in life. You have to be good at something. At least
buy these planes. I am everything else. I'm a dumb person. Very much. So one thing about drones, since we say they are communicating by signals, we have signals all over. Your phone is emitting a Wi-Fi signal, all those. So all of those interact with drones. So what happens is, whenever you are turning on a drone, you first always turn on the remote. So that you don't turn on the drone first before the remote, and now the drone picks up any random signal and tells itself to do anything. So for instance, if I connect this one here, you might find it just powering up without me telling it to power up. So you see that's a danger, because you might be there on the propeller or something like that. So that's why we always start with turning on the remote. So those are its own diagnostics.
All right.
Then we cover it up. Then we do some basic controls check. We first start by our propeller. We have something we call a kill switch, which is this one, so that you don't accidentally power it up. Yes, so that you might be fixing it and you accidentally power it up. So let me start with the basic controls. We have that is our propeller. So it's now when you launch it by hand, there's no friction, so it just flies. Yes, this hand launched.
All right.
You hold it by hand and you toss it into the air.
All right.
Then we have the control surfaces.
Yes.
If I want to aileron,
Yes.
that is it.
Yes.
So one should go up and the other one should go down.
Ah.
So that one wing goes up
Okay.
and one wing goes down.
So like when this one now like goes up, it will turn to
No, when this one goes down, it will turn this way. Because now this side will produce more lift and that side will produce less lift. So the aircraft will go that way.
Right.
When we do that, when that one goes down, more lift on that side, so the aircraft goes like this.
Oh,
Yes.
right.
Now that is our aileron.
Yes.
Then we have elevator.
Yes.
Our elevator.
Okay.
This one. When it goes up,
Yes.
your aircraft goes up.
Oh. Right.
When it goes down,
Yes.
your aircraft goes down.
Okay.
Pitch down.
All right.
Pitch up.
I have a question.
Yes, sir.
This same principle, is it the one that is used to prevent race cars from lifting themselves? Because
Yes.
they have some, I think, a tail.
Spoilers. Now
Yes,
we call them
spoilers.
spoilers.
Yes.
Yes, but they work basically the same.
All
It's
right.
basically the same operation principle.
Okay.
Operating principle.
All right. So that the ones at the back, what movement do they control?
Pitch.
Or pitch and.
Yes, pitch
Oh.
up
Uh-huh.
or pitch down.
Okay.
So the nose goes up
Yes.
or goes down.
All right.
So when it's that way, the
Yes.
nose goes up.
Okay.
When it goes down, the
Yes.
nose goes down.
All right.
Yes.
There's another movement you talked about.
Yes, you.
Yes. Yeah, that
This
one.
way and that way.
Yes.
Which is that?
Oh, this
What?
one here. So this one here is
The
moving.
rudder.
Oh, okay.
So when it goes to this side, the
Yes.
aircraft goes this way.
Okay.
When it goes to this side, the aircraft goes this way.
Oh, okay. This looks something ingenious too, huh?
So those are the basic control inputs
Alright.
in the aircraft. Now flying is about using them all together.
Oh, you have to combine them.
Yes.
And now that's the real education.
Yes, now that's because for instance now we are turning.
Yes.
As I am turning that way,
Yes.
I also need to pitch up a little bit because when you turn, your aircraft nose tends to go down. So I need to pitch up a little bit. And when I pitch up a little bit, I need to add more power because the aircraft needs more power so that it does not stall.
Alright.
Now you do all those together simultaneously. Then after you are done, you must get out of that, so you do the reverse of that. So now getting that, the half of them together
Okay.
is the
What about when you put the plane on autopilot?
Yes.
Can an autopilot start a plane from the ground, or it has to be on air?
Yes, the autopilots with our current generation,
Yes.
as of now, drones, we have the autopilot is called autonomous flying.
Yes.
That thing will take itself off,
Yes.
go fly its mission and come back land without human intervention.
Wow.
Your intervention is only the control input
Okay.
and the GPS waypoint. So the systems are coming in
Yes.
great with the automation.
Oh, that's interesting. So we've come to the end of our interview. Unless there's anything else you wanted to add, perhaps you can tell us if there's anything you want to add on top of what you've told us.
Yes, mine will be to encourage more people to explore into aviation.
Yes.
Aviation is an amazing world.
Yes.
Aviation will open up doors to you that you have never thought of. And it's a very wide discipline. Only that many people think it's based, it revolves around the pilot. No. There are many careers in aviation that one can take.
Okay.
You can become an aircraft technician, you can become a fuel person, you can become the cargo person, you can become the flight dispatcher. So many things that are there present in aviation that people ought to explore. Don't be scared about joining aviation.
Yes.
You should also consider enrolling in flying drones and get an RPL.
Yeah.
Yes.
What's RPL?
It's the remote pilot's license.
Okay.
Yes.
I will consider that
You
because
should.
one day I
Yes.
would want to tell stories from a plane.
Ah, that's very wonderful.
I've told stories about a man who makes planes.
Yes.
Now I want to tell a story when I am inside one.
That's sure.
Thank you so much.
You're very welcome.
Yes.
I much appreciate your time.